Supersymmetry is the transformation between the fermions and boson. On the supersymmetric Lagrangians is which means that the Lagrangians are invariant to such a supersymmetric transformation. And such a supersymmetric Lagrangian can be constructed by the superfield, which is the best well-known example is the Kara superfield and the vector superfield. Color fields consist of the spin zero color field and the spin one half spinor field. And the vector field case spin one half spinor field and the spin one vector boson field. And there will be some additional auxiliary fields, some like the up and D, but it will be ignored because they don't have the kinetic term Lagrangian, so they can be moved. So there are some of the three types of the supersymmetric Lagrangians terms. The first term is gauge-based interaction. Actually, the pi daggers, the pi is becomes the vector superfield because the pi dagger pi and total complex conjugates become that is solved, so it satisfies the condition of the vector superfield. And there will be some exponential of the vector superfield is also is that the expansion series of the vector superfield, and it will stop in the second derivative second term because in the Bausch-Schmidt model, V becomes the zero. Because of Grossman numbers, the anti-commutative identity. Second possible term is superpotential, which it consists of the expansions of the product of scalar superfields. So, for example, pi i, pi j, pi k term can be possible. Also, just the pi I, pi j is just the two products of the two color superfield, and the superpotential that consists of the such terms. And we will only consider the finite series expansion of the superpotential to make dimensionless coupling polynomial Lagrangians. The other possible term is the supersymmetric field strength, which is WA. It defines it as covariant derivatives with the vector superfield. That's some generalization of the field strength in the standard model menu, which is derivative commutative relations of the covariant derivatives and the gauge bosons, and there is some generalization in the supersymmetric version. And such as twice of the supersymmetric field strength, it becomes the color superfield, and we will denote that for the vector superfield, the term for the D terms, so only contributes to the supersymmetric Lagrangians, and the up terms of the color superfields that only contribute to Lagrangians. Now, from now we'll define what is the determinant outcome. First of all, there are some identities of the Grossman numbers integration. Because the action is defined in the supersymmetry theory is integration over the space times, and also integration over the Grossman number variable, because the superfields that defines of the such a superspace. And there is some Lagrangians, which is a function of the some field defined the space time and the superspace. And we want to obtain the Lagrangians only depends on the superfield with the defines on the space time. So such integration variables of the Grossman numbers should be the integrates out. And there are some of the identity of the such a Grossman integration. First of all, this Kiyosada with the correct of the Grossman number variables is the one. So such as the quadratic Sada and the Sada. So only such a coefficient Sada and Sada that only the will be the turns out for the this integration. So if we integrate vector superfields from the Kiyosada and Kiyosada, the coefficients of the Sada and Sada of the such a vector superfields will be the turns out, and it is called the D term. And such as why we find this such as D terms is the such a zeta-zeta zeta-bar coefficients of the vector superfields is actually the invariant around the supersymmetric transformation, which is describes the total derivatives. And similarly, we can define the upterm. First of all, there are some identity integrations of the scalar superfields over the discrete setup with the quadratic form, which is becomes the delta function, so that the theta equal to the 0, the cross numbers for the theta equal to 0. So if we integration over the scalar superfields over the discrete setup and discrete setup bar and the delta function, then the first of all definition of delta function theta bar becomes the 0, and the remaining integration variable is discrete theta. By the identity discrete theta quadratic terms becomes the ones. The coefficients of the theta components of the color superfield will be yielded as called upsum, and because we extract some upsum from the color superfield, because such a theta coefficients of the color superfield is invariant to the supersymmetric transformation because of the some total derivatives of form. So now we can write the options as integration of the space-time and the superspace for the vector superfields and the Hermitian conjugates of the chiral superfields pair. And we can obtain the Lagrangians, which defines as a function of the field over the defines of the space-time. So that's some of the definition of the Dian upstem. Actually, why we define the determinant upstem like that, because the supersymmetric transformations actually the expands is across one variable and the supercharge operator. And if there are some of the total derivative term, it becomes to 0. So supersymmetric invariance terms can be possible by the total derivative terms by the supersymmetric transformations of P's. Now we want to talk about some several terminal supersymmetric Lagrangian. The first case of the gauge interaction you already mentioned. Such a pi dagger pi sort of terms are actually the coefficient theta and theta bar. And such a scalar superfields can be written by the scalar superfields and the spinous superfields and the and it is the defines of the basis of the y. And if we expand the x again, then there will be some of the derivative term will be appear. And the pi dagger and the pi such a coefficient can be written by like that. There are some derivative term and the such as some of the set about psi and the psi terms with the some Dy equation forms will be appear because the such a there will be the set of psi and the above psi terms, and those partial terms will appear. So we can calculate like that. And such a partial means that the pi case terms is a similar forms of the kinetic term of the color field, and such auxiliary sum can be removed by the Euler-Lagrangian equations. And it is an invariant of the gauge transformation too. And such as some of the expansion of the scalar superfields in terms of the arcs will be discussed in the another video. And such exponential sort of the vector superfields stops in the second term because with those powers it becomes a zero zero vast in the guides. So such a pi dagger's exponential of the vector superfield and the pi sort of the terms will be that the such a term covariant derivatives will be the instance for the kinetic term for the scalar fields and the spinor fields, and after the fields terms the also touch it, and there are also some additional interaction term. There will also d terms will be appear from the vector superfields auxiliary fields components, and there will be the interaction term between the scalar and spinor and the which is lambda, which is some of the gauge, in the such a covariant derivatives, there will be some of the gauge was will be appear, and such a lambda is the superpartition of the such a gauge was also called the gauge, So gauge, is a spin 1/2 particle. So gauge users and the fermions colors interactions can possible in the such as some gauge interactions, supersymmetric Lagrangian term, and is actually the one gauge new part to just the displaced super particle, which is for particle gauge new. The second possible term is superpotential, which is expansions of the products of the color superfield as a polynomial. We only in terms of the positive dimension and the dimensional scattering. And such as after of the such as potential is actually the set of the coefficients of the such as the superfields, and the just given like that, and such as terms have a very important role in the interaction term. And the third possible case is supersymmetric strengths, which is defined as with the covariant derivatives on the vector superfields, and such as twice of the symmetric field strength is actually the color superfields optimum of the kinetic terms of the gauge boson fields and the kinetic term for the gauge inner field. So that is not the supersymmetric Lagrangian, and it can be used for constructing sort of the minimal supersymmetric standard model, so-called MSSM.